everyone. Welcome to LJIP e-learning session, initiative taken by Lok Jagrati Kendra. Myself Prachi Joshi from Department of Pharmaceutical Technology, LJ Institute of Pharmacy will be teaching evaporation in this session. The main objective of this session is to understand what is evaporation, factors affecting evaporation, and also we'll be seeing some of the evaporators. Now, what is evaporation? Now, it can be termed as a process of vaporizing large quantity of volatile liquid to get a concentrated product at any given temperature from the surface. So, it is also known as surface phenomena. Now, why it is known as surface phenomena? Let's take an example of a liquid which is taken into a container, basically an open container. So, and it is exposed to any given temperature. So, because of this temperature, what happens is the molecule which is present inside the liquid will collide with each other because of the random motion. So what happens is they will possess some kinetic energy, and the molecule will possess high kinetic energy molecule and low kinetic energy molecule. The high kinetic energy molecule will move towards the surface, and they have weak intermolecular forces, and plus they are having low boiling point, and because of this reason, for them to escape from liquid phase to the vapor phase becomes very easy from the surface, and so it is known as surface phenomenon. Okay, so why is evaporation different from drying, distillation and crystallization? So firstly, evaporation, okay, the residue which is obtained is always liquid one, while in the case of in the case of drying, it is always a solid one. In the case of distillation, the component which is exposed to heating is two or mixture of three maybe. But in case of evaporation, mostly it is always one. Now in the case of crystallization, heating is done till you obtain crystals as the end product. While in the case of evaporation, it is always concentrated liquid but not the crystals. Okay. Now, all this process is depending upon various factors which is affecting the process. Now, as you can see, the different kind of factors are enlisted like temperature, surface area, moisture content, vapor pressure, time, film and deposits, etc. This can be also explained mathematically, like as you can see on your screen, there is equation m is equal to Ks upon rho b minus b dash, where m represents rate of evaporation, K as constant, S as surface area, rho as atmospheric pressure, while b is the vapor pressure of the air, while b dash is the vapor pressure of that particular liquid which is exposed to evaporation process. Now firstly, temperature. Now temperature has a direct relationship between the vapor pressure. So if the temperature is high, the vapor pressure will be high. Why? Because the high kinetic energy molecule will move towards the surface and will pass to the vapor phase, right? So the vapor pressure above the liquid will increase, and because of that the process of evaporation will also increase. But now when the temperature increases, some kind of liquids, or you can say components, may get degraded, right? Like enzymes, hormones, antibiotics, or some plant components like glycosides and alkaloids. So you need to design or use specialized evaporation process to prevent the decomposition of such products, right? Now let's take the second factor, that is vapor pressure. As we have already discussed that the rate of evaporation is directly proportional to the vapor pressure of the liquid. Higher the vapor pressure of the liquid, high is the rate of evaporation. But now here the role of atmospheric pressure also plays the major role, right? So atmospheric pressure here in this equation is inversely proportional. So if the atmospheric pressure is high, the rate of evaporation decreases, okay, and if it is having low atmospheric pressure, then the rate of evaporation increases. Similarly, with surface area, it is also directly proportional according to the equation. So anything which is having a direct relationship will act accordingly. So if the surface area is large, then evaporation process also increases. Now, moisture content. The moisture content, if it is very large, then it will take more time to get evaporated. And even the drug constituent which is there having the moisture content will undergo hydrolysis when it is exposed to high temperature. So in the process of evaporation, what happens is initially that kind of component is given low temperature, and as you go beyond it, the temperature is gradually increased. Okay. Similarly, type of product required. So if you require liquid or dry concentrate, then you can use open pan evaporator. So ultimately, type of product which you require decides the apparatus to be used for evaporation. Now next is time of evaporation. If the time of evaporation is longer, greater will be the evaporation. But the only condition is the constituent which is present should be thermostable one, or it may get degraded. Now film or deposits. Now when any concentrated liquid is taken into a heating pan for evaporation, a film is formed inside the instrument, right? Why? Because the constituent which is there will form a layer. The solvent will get evaporated. Okay. So because of that, that process of film forming or precipitation forming will hinder the process of heating, or you can say evaporation. Now, we will be learning about different evaporators. First one is steam jacketed kettle or evaporating pan. It is similar to the cooking pan, in which we use direct heating flame, but in this we will be using steam to supply heat. Steam is supplied to the evaporating pan, in which there is an aqueous extract. Now the steam gives out heat to the kettle, and the heat is transferred to the basic principle of conduction and convection. As a result, temperature rises and molecules get evaporated. Now, we'll be moving to construction. As you can see in your figure, there is a kettle now which is jacketed by the jacket, which has steam inlet, air outlet, condensate outlet, product outlet, and the aqueous extract is evaporated from the top. Now, the kettle is single sheet or multiple sheet. If it is a single sheet, then there will be small amount of sample. But if the sheet increases, then it is used for large quantity of sample. The kettle is made up of copper, for it is a good conduction of heat. Now, it is also tinned from inside. It is also known as tinned copper, as it is used for acidic material. Now, working. Aqueous extract is placed in the evaporating pan. Steam is supplied through the inlet. Now, the steam is supplied between the hollow path where the jacket and the kettle both are joined together. Now, the content is stirred continuously so that the evaporation process is increased and it becomes faster. The rate of evaporation is fast in the initial stages, but it decreases gradually as the liquid gets concentrated, because it forms the film, and which is hindrance to the heating. Now, on the top, the solvent gets evaporated, so ventilation should be provided to remove the vapors. Now the concentrated product, or the liquid product you can say, is collected from the bottom, as we have seen in the figure. The major advantages are, it is used for both small scale as well as large scale. It is simple in construction and easy to operate. Even the maintenance and installation have both low cost. But the major disadvantages are heat is economic, is less, not suitable for sensitive material, that is heat sensitive material. Third, heat transfer rate decreases drastically when the concentration gets increased. As I told you, it forms film. It is used for concentrating aqueous and thermostable liquids. We can take example of licorice extract. Now we'll move forward with the second evaporator, and that is horizontal tube evaporator. Here also we will be supplying steam to the content. So the basic principle remains same, that is conduction and convection. So we will be moving towards the construction. Now as you can see the figure, there is a cylindrical body which is large enough, or you can say dome shaped from top and bottom. It is made up of cast iron, or you can say plate steel. The height is about 2.4 to 3.6 meters and the diameter is 1.8 to 2.4 meters. Now, the lower part of this cylindrical body has, as you can see, the horizontal tubes are arranged. These horizontal tubes are for providing the steam to the liquid which is there in the steam compartment. There is vent, there is a condensate for collection. A vent is used for collecting non-condensed gases or liquid. Now, condensate is collected from the condensate bottom and steam is provided from the steam inlet, and the solvent gets evaporated from the top. Now, these horizontal tubes are made up of stainless steel and they are arranged in the range of 6 to 8 in the steam compartment. Now, working. The fed is introduced into the evaporator in such a way that these horizontal tubes get immersed. Okay. Now, steam is introduced into the steam compartment from the steam inlet. The horizontal tube receives the heat from the steam by conduction and convection. Steam condensate passes through the corresponding outlet. The fed absorbs heat and the solvent gets evaporated. The vapor escapes through the top. As you can see in the figure, there is solvent evaporation provided on the top dome. Now, this process is continued until a thick liquid is formed, which can be collected from the bottom. Now, the major advantage is low cost or cheap, easy to install, requires less space for installation, suitable for liquid that cannot be crystallized, can be used for both batch as well as continuous operations. But the major disadvantage of this is it is not suitable for viscous liquid. Now, because the major reason for it is it has poor circulation. You cannot get continuous circulation, right? Now, uses is it is used for non-viscous solution that do not deposit scales or crystal on evaporation. Example, cascara extract. Now we'll move forward with vertical evaporator, which is similar to that of horizontal tube. It is also known as short tube evaporator. Now construction is more or less same as that of horizontal tube. Only thing is, in horizontal tubes are arranged in a horizontal fashion, but here tubes are arranged in a vertical manner. Now, the major construction is it consists of a large cylindrical body made up of cast iron, or you can say plate sheet. Now, it is also similarly dome shaped from top and bottom, where vent is provided, steam inlet is provided, vapor outlet on the top is provided, and in the bottom there is, you can say, the concentrated liquid product is collected. Now, this horizontal tube is also known as calandria. These calandria increases the surface area for steam circulation. Now, the diameter of this is 0.05 to 0.075 meters. The length of calandria is 1 to 2 meters. Now, there are hundreds of tubes, you can say. Vertical tubes are placed where the diameter is 25 meter or more. Now, working. As you can see, liquid is passed through the vertical tubes. Now, liquid fed, which is introduced, is filled above all these tubes so that it is sufficiently filled enough for the circulation. Now, steam is passed from the tube outside. Now, the liquid inside the tube gets heated by conduction and convection. Now, the liquid inside the tube starts to boil, and while boiling it will raise up and then it will move to the central part and then it will come back downwards. Now, this continuous circulation helps to efficient boiling and passing from the surface the high energy molecule above the surface and pass through vapor phase, and this is known as evaporation. Now, the concentrated liquid, our liquid product, is collected from the bottom similar to the horizontal tubes. Now, the major advantages of this is the tube increases the surface area nearly, you can say, 10 to 15 times, and the vigorous circulation enhances even the rate of evaporation. But the major disadvantages is it is complicated as well as expensive. It is used for manufacturing of cascara extract, sugar, salt and even caustic soda. The rest of the evaporator will be seen in our next video. Up till then, thank you. Stay in, stay healthy and stay safe. Thank you.